Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Of course, if my videos are important to your studies, don't forget to subscribe. Determine the maximum values of the following: reaction at B, shear at C, M sub C, moment at center, and the absolute maximum moment. So we imagine that the loads move from left to right because we want to maximize RB. So when load 6 is over B, definitely the criterion for delta VR would be positive. And since distance between loads is less than 10 or less than 5, there will be no P1 there will be P1H over L. So, and there is also an incoming load definitely. So our criterion would be delta VR equals WH over L minus P1 then plus PD over L only. There will be no P1H over L. For this case, there will be P1H. There will be no P1H over L because we are computing for the reaction. So load 5 over B. When load 6 was over B, 4 plus 4 plus 4 plus 3, that's 15. So the 2 kilonewton load is over A when load 6 is over B. Now that load 5 is over B, that means 30 enters a distance of 4 plus 4, 11, plus 3, 11, plus 2, 13. So the 30 kilonewton load enters 2 meters to make it 13 plus 2, 15. So this is an incoming load. Our W would be 60 plus 50, 110, 170, 210. W is 210, H is 4, P1 is 50. So delta VR is 210 times 4 over 15 minus 50, then plus 30 times 2 over 15. And that is positive. So next, load 4 over B. There will be no incoming load already. Load 4 over B, P1 is 60, H is 4, and W is 50 plus 60, 110 plus 40, 150, 180. So delta VR is 180 times 4 over 15 minus 60, then plus, that's it only. So it is negative. Therefore, preceding position, because this is load 4 over B, the preceding position, load 5 over B, gives maximum reaction at B. So therefore, load 5 over B gives maximum reaction at B. So summation moment about A equals 0, RB times 15 equals, take note, load 5 is over B, so equals 60 times 15 plus 50 times 11, because 15 minus 4 is 11. 11 minus 4 is 7, so plus 60 times 7. 7 minus 3 is 4, so plus 40 times 4. Then 4 minus 2 is 2, so plus 30 times 2. So RB max is equal to 139.3 kilonewtons. Next, for shear at C, the criterion will be WH over L minus P1 plus P1H over L, because the distance between loads is less than 5. We now imagine that the loads move from right to left this time. Then plus PD over L if there is an incoming load. So criterion delta V is WH over L minus P1 plus P1H over L plus PD over L. So when load 1 is over C, definitely this is positive, there will be no minus. So let's proceed to load 2 over C. Load 2 over C. So when load 1 was over C, 2 plus 3, 5 plus 4, 9 plus 4, 13. And because this is 2, when load 1 was over here, this 60 kilonewton load was outside. When load 2 is over C, 3 plus 4 is 11, and 60 kilonewton is also outside. There will be no incoming load. So load 2 over C, W would be 40 plus 60, 110, 100 plus 30 because load 1 is still over the span. 130 plus 50, 180. So delta V sub C is 180 times 2 over 15 minus 30 plus 30 times 2 over 15. That's the only criterion. There will be no incoming load. So it is negative. So that means preceding position of load 1 over C gives maximum shear at C. So load 1 over C satisfies the criterion. Then let's proceed. Let's have load 3 over C. So W would be 180. Load 3 over C. So that means the 60 kilonewton load enters distance 2 because 4 plus 4 is only 8 and this is 10. So this enters 2 meters. All these loads are still on the span. That's why W is 50 plus 60, 110, 150, 180. And our P1 is 40. H is 3. Then minus 40. Then plus 40 times 3 over 15. Then incoming load 60 times 2 over 15. So it is positive. Next, load 4 over C. When load 4 is over C, this is an incoming load because 4 plus 4 is 8. This enters 2 meters. But W would be, this is somewhere here, so W would be 60 plus 50, 110, 170. So delta V sub C is 170 times 4 over 15 plus 50, minus 50, minus 60 rather, because load 4 is over C, minus 60 plus 60 times 4 over 15 P H over 15, then plus this enters, so plus 50 times 2 over 15, and it is positive. Next, load 5 over C. Load 5 over C, so there will be no incoming load. Then W is 50 plus 60 plus 50, 160. H is 4. P1 is 50 this time. So minus 50. Then there will be no incoming load, so just P1H over L, so plus 50 times 4 over 15. And the sign is still positive. Load 5 over C. So next, load 6 over C. These are the two remaining loads. So W is 110, 60 plus 50. P1 is 60. So 110 times 4 over 15 minus 60. Then plus P1H over L plus 60 times 4 over 15. And it is negative. So let's evaluate two situations. The preceding position, load 5 over C, satisfies criterion. load 5 is over C. This is when load 6 is over C, but the preceding position, load 5, is over C. So when load 5 is over C, take note that the 50 kN load is still on this one. So let's evaluate this case. Load 1 over C. So let's solve for RA. RA times 15. So load 1 is over C. So equals 30 times 10. Then plus 40 times 8. 10 minus 2 is 8. So that 2 kN, the load 2 will be somewhere here, 2 meters from C. So that's why its moment arm from B is 8. 8 minus 3 is 5, so plus 60 times 5. Then 5 minus 4 is 1, so 50 kN load will be 1 meter from B, plus 50 times 1. So RA is 64.67 kilonewtons. Therefore, shear at C is RA. RA equals downward positive shear at C because load 1 is over C. So RA equals shear at C. So maximum value of shear at C 1 is 64.67. Let's compare it with the shear when load 5 is over C. So when load 5 is over C, RA times 15, summation moment B equals 0. So take note, load 5 is over C. 50 kilonewton load is here. It is 4 plus 10, so 14 meters from B. So plus 50 times 14 equals 50 times 14 plus 60 because load 5 is over C, 60 times 10. And 50 is 10 minus 4, 6 meters from B. So plus 50 times 6. So RA equals 106.67 kilonewtons. So shear at C is RA minus 50 because 50 is part of the FBD in AC. So shear at C 2 is 106.67 minus 50 is only 56.67. So this is greater, therefore maximum shear at C is 64.67. Then for moment at C, the criterion is W over L minus W1 over A. A is 5 or equals 0, or W over 15 minus W1 over 5 equals 0. So this reduces to W over 3 minus W1. So moment at C is possibly maximum if the heaviest load will be over C. But let's consider first load 2. When load 2 is just to the left of C, because when load 2 is just to the right, only 30 will be involved and definitely it will give us positive. So load 2 over C just to the left so that it is part of W1. So when load 2 is just to the left, just to the right, W delta MC equals W 180 over 3, then minus 70. Load 2 is just to the left. So W would be 30 plus 40, 70 plus 60, 130 plus 50, 180. Because 60 kilonewton load is still outside. So W would consist only these 4 loads when load 2 is just to the left of C. And 70 is 30 plus 40. So the sign is negative. So preceding position, load 2 over C, just to the right of C or over C gives possible or satisfies the criterion, but not necessarily maximum. So will 2 over C. Next, will 3 just to the right of C. When load 3 is just to the right of C, then W would change. This is part of W. Ready? So 70, 130, 70, 130, 180 to 40. But W1 is 30 plus 40 only because load 3 is just to the right. So definitely it will give us positive value. So 240 over 3 minus 70, 30 plus 40, it's positive. So next is load 3 over C just to the left. So 60 will be part of W1 and 30 is no longer part because it is just to the left of support A. So W1 would be 40 plus 60 only when load 3 is just to the left. And W would consist 40 plus 60. This is no longer part of W. 40 plus 60, 100, 150, 210. So 210 over 3 minus 100, where 100 is 40 plus 60. And it is negative. So that means preceding position, load 3 over just to the right of C or over C satisfies a criterion. So will 3 over C for this situation. Then let's also consider will 4. And we will no longer consider will 5 and will 6 because they will satisfy definitely but give lesser moment. I already checked that. So will 2 over C. So let's just compare these two because this is already the heaviest load over C. So if it is 40, it will be less. If it is 60, it will go back to greater, but only few loads will be on the span, just like when will 3 is over C. All these loads are on the spans, these 5 loads. So, or these 4 loads, because 30 kilonewtons will be over A when load 3 is over C. So there's a great possibility that will 3 over C gives maximum moment at C. So when will 2 is over C, so let's solve for RA times 15, summation moment B, will 2 over C, so will 1 is 2 plus 10, 12 meters from B, so plus 30 times 12, then will 2 over C, so plus 40 times 10, 60 will be 10 minus 3, 7 meters from B, so plus 60 times 7, 50 will be 7 minus 4, 3 meters from B, plus 50 times 3, and 60 is outside. So these are the only loads to be considered. So RA is 266 over 3 kilonewtons. So this is will 2 over C. So therefore the moment at C is RA times 5 minus 30 times, because will 2 is over 3, 30 times 2. So MC1 is RA times 5, 266 over 3 times 5 minus 30 times 2. And it is equal to 383.3 kilonewton meter. Then will 3 over C, the other situation. So let's solve for RA times 15. If will 3 is over C, 30 is over A, so equals 30 times 15 plus 40 times 13, 15 minus 2 is 13, plus 60, 60 is over C times 10, plus 50 times 6, because 10 minus 4 is 6, then plus 60, 6 minus 4 is 260 times 2. So RA is 398 over 3 kilonewtons. So when load 3 is over C, maximum moment at C is RA times 5 minus 30 times 5 minus 40 times 3. So MC2 is 398 over 3 times 5 minus 30 times 5 minus 40 times 3. And it is 393.3 kilonewton meter. Because this is greater than this, so maximum moment at C is 393.3 kilonewton meter. So that's it for this part. Moment at center. Let's have it on the next. So for part D, moment at center, our criterion is delta M equals W over L minus W1 over L over 2, or 7.5 equals 0, half of 15. Then that reduces to W over 2 minus W1. So because earlier, in the preceding slides, load 3 satisfies the criterion, this time let's have loads 3 and 4 over just to the left or just to the right of the center line, because we already considered load 2 and it was lesser at C. So it will also be lesser at center because it's only 40 kilonewtons compared to 60 kilonewtons. So let's have loads 3 and 4, because if we consider load 5, that's also fine, but they will be closer to the supports. The 50 and this 50 kilonewton load will be closer to the supports. Whereas if load 3 is over the center line, 40 and 30 will be close to the center. 50 is the same, close to the center, and 30 is also included. So there will be many loads if load 3 is over the center compared to load 5 over the center. So this gives greater moment at the center line than load 5 at the center. So let's consider 3 and 4. So delta M would be 180 over 2. Load 3 is just to the left of the center line. So minus 70. W1 would be 30 plus 40. Load 3 just to the right of the center line. So it's not part of, if this is the center line and it is to the right, it is not part of W1. Only 30 and 40 will be part of W1. And W would be 70 plus 60, 130, 150, 180. For this load 5 will be off span because the distance between 3 and 5 is 8 and half of the span is only 7.5. So 60 kilonewton load will be off span because it is 0.5 from B, 0.5 meter from B. So the sign is positive. So next, load 3 just to the left of the center line. So it is part of W1. W would still be 180. So 180 over 2 minus 70 and 60 is negative 130. So it is negative. So that means load 3 over C just to the right, or load 3 over the center line just to the right, is the same as load 3 over the center line gives or satisfies the criterion. So wheel 3 over center line. Then let's consider load 4. Load 4 over C just to the right. If load 4 is just to the right of the center line, then 50 is out because 4 plus 4 is 8, greater than 7.5. or half of the span, and W would consist only of 40 and 60. 30 will be out of span also because 7 plus 2 is 9, 3 plus 4 is 7, so 40 is part of W1 and 60 part of W1. So W would be 40 plus 60, 100 plus 50, 150 plus 60, 210. Again, 50 is out of span. So 210, but W1 would only be 40 and 60 or 100. So 210 over 2 minus 100 is positive. But if load 4 is just to the left of the center line, it is part of W1. So W1 would be negative 150. W would still be 210. So 210 over 2 minus 150 is now negative. So that means load 4 over wheel 4 over center line also satisfies the criterion. And the rest will satisfy, but that gives lesser value. So let's just evaluate these situations: wheel 3 over center line and wheel 4 over center line. First, for wheel 3 over center line. So let's solve for RB. So that maximum moment at center line is RB times 7.5 minus 50 times 4. So that's our working equation. Or if we solve for RA, then moment at center line is RA times 7.5 minus 40 times 3 minus 30 times 5. So let's load that. 30 times 12.5, where 12.5 is 2 plus 3 plus 7.5 plus 40 times 10.5 plus 60 times 7.5 and plus 50. 7.5 minus 4 is 3.5. 50 times 3.5. So R sub A is equal to 284 over 3 kilonewtons. So M center line 1 maximum possible is RA 284 over 3 times 7.5 minus 30 times 5 minus 40 times 3. So maximum moment at center line 1 is equal to 440 kilonewton meter. Next, load 4 over center line. So this will be the loads that will fit on the center line. The 50 kilonewton load will be outside because the distance is 4 and it exceeds 4 plus 4, 8, 7.5. So let's solve for RB this time. RB times 15. So that maximum moment on the center line is RB times 7.5 minus 60 times 4. So equals 40 times 0.5. This is 0.5 because 4 plus 3 is 7. And this is 7.5. Plus 60 times 3.5. Plus 50 times 7.5. And plus 60 times 11.5. 7.5 and 4 is 11.5. So R sub B is equal to 259 over 3. So M center line max 2 is RB times 7.5. 259 over 3 times 7.5 minus 60 times 4. So it is 407.5 kilonewton meter. It is less, so therefore maximum moment at center line is 440 kilonewton meter. For absolute maximum moment, we already know that it occurs between load 3 and if it is close to the center line. So let's have this situation. So this is load 3 and the resultant should be somewhere here. So that midway between them is the center line of the beam. That's the principal. So R is 30 plus 40, 70 plus 60, 130 plus 50, 180. And the distance between R and 3 is E. So to solve for E by Varignon's theorem, 180 times E equals 40 times 3 plus 30 times 5, then minus 50 times 4. This is our reference. Absolute maximum moment occurs under load 3. So E is 7 over 18 meters. Therefore, E over 2 is 7 over 36. The distance of load 3 from the right is 7.5 minus E over 2 minus 7 over 36. So 7.5 minus 7 over 36 is 263 over 36. Likewise, the distance of R from A is also 263 over 36. So summation moment about A equals 0. To solve for absolute maximum moment, it is RB times 263 over 36 minus 50 times 4. That's our working equation. So solving for RB times 15 equals 180 times 263 over 36. So R sub B is 263 over 3 kilonewtons. Therefore, M absolute max is equal to RB, 263 over 3 times 263 over 36 minus 50 times 4. So M absolute max should be greater than this. It is 440.5 kilonewton meter. So the value is slightly greater than that. But because this is absolute, that's the maximum absolute moment in the beam. So that's it, and I hope that you were able to follow the solutions and explanations.